Welcome to the Infrared Spectrum for Friday, April 7th. I can't wait to show you what my class in Fairfax, Virginia found last week. One of the hottest anomalies that I've seen in 15 years of teaching. More on that in a moment. First, the latest news from the Infrared Training Center. Are you thinking about perhaps getting into aerial infrared inspections with drones? Or maybe you're already using SUAS with thermal imaging, but haven't completed formal training yet. We've got a number of UAV classes coming up later this year, including Atlanta this month. The SUAS Level 1 Thermography Certification course is geared towards individuals who need infrared training focused primarily on aerial IR and its many applications. This course will also cover a variety of condition monitoring and predictive maintenance situations, plus discuss the types of aerial equipment, the business environment, regulatory issues, and much more. It's the perfect class for those who are looking to enter this exciting and rapidly growing field. To learn more and register, go to infraredtraining.com/schedule, give us a call on our 1-866 number, or send us an email. Hope to see you there. So, I'm in Fairfax, Virginia last week at our Level 1 Infrared Certification course, and this happens. It's the third day in the afternoon. We're running some hands-on exercises. We come across this pretty significant thermal anomaly. Now, it's significant for the fact that we've got windy conditions here and some pretty direct solar loading. So it's amazing that this even showed up to begin with. The max temperature that we're seeing here, over 500 degrees Fahrenheit. That's 260 degrees Celsius, and likely even warmer. And as I mentioned, wind was a factor. We were witnessing the temperature varying significantly throughout the exercise. Now, there's also an issue with emissivity here too. Because we were not able to properly measure it, however, we simply left it at 1, which really gives us a minimum threshold for temperature. We know it's not any colder than that, and likely much warmer. Well, I also feel comfortable saying that too, though, is because of resolution. And that's what I wanted to talk about today. Spot size ratio and its impact on temperature measurement. Spot size ratio, though, is all about resolution. And to understand resolution, we first need to know that the image is built from pixels. A thermal image that you see here, if we were to take a magnifying glass and look very closely, you would see the individual detector elements that make up the focal plane array, which is the sensor that sees infrared radiation. And with the more detectors that you have, the more pixels, the more detail you're going to capture. We have two examples here of two different size detector arrays. On the left, one that's an 80 by 60, on the right a 640 by 480. Now those numbers indicate how many detectors are across both the horizontal and the vertical here on the thermal image. On the left, an 80 by 60, we can see that we get limited detail. But on the right, with a 640 by 480, more detectors means more resolution. But that's only part of the resolution equation. We also have to bring into the discussion here what type of lens you're using. But to talk about lens, we have to first look at what's called the field of view. Now, your camera's field of view is everything that you see on the screen. That represents your entire field of view. And that's measured in degrees. It really depends on the size or the type of lens that we're working with. The standard lenses on most infrared cameras is around about 25 degrees or so, and that's the width horizontally that we see here. If we were to look at this sort of from a bird's eye view perspective, that 25 degrees would be 25 degrees across the horizontal. So if you were standing here and had a camera with a standard lens, your field of view would be 25 degrees in size. Well, what resolution is all about is how much detail can we see of a certain sized object at a given distance. And that's where the instantaneous field of view comes into play here. What the IFOV is the projected size of just one of those detectors within the overall field of view. So for illustrative purposes here, we have what would be a 9 by 7 focal plane array. That is, there's 9 pixels across the horizontal and 7 on the vertical. One IFOV is what one of those pixels is seeing. Another way to illustrate this is to imagine you're imaging a house. But instead of standing on the front lawn, pretend that house is down the street, at the end of the block. If you took your 9 by 7 focal plane array and tried to get a thermal image of that house, you're not going to get a lot of detail. Maybe 1 pixel might detect that house. It'll be a hot dot in the image. To get more resolution, you got to get closer. By getting closer, you put more pixels on the target and you capture more detail. That's the essence of resolution. So in this example here, we have a house in cold weather conditions with what appears to be some missing insulation here up on this dormer. Now I want to get better resolution. I really have two options at this point. I can get closer, or if I want, use a telephoto lens with a narrower field of view. That narrower field of view will put more pixels or more detectors on the target. And by putting more detectors on the target, I'm going to capture more detail. But IFOV is only about detection. We want to get a temperature measurement, and that's where the measurement field of view comes into play. You see, with instantaneous field of view, it's about getting detectors on the target to capture detail. Measurement field of view, that involves the spot size, what we call the spot meter, perhaps the reticle, and that's filling that spot meter completely to get the best resolution for the most accurate temperature reading. And the size of that spot meter can vary. It's either 3x3 or 4x4 depending on the type of camera that you're working with. There's a great demonstration we run with one of our labs inside our Boston Regional Training Center involving a fuse cutout that's on the back wall. And on it there's a 1-inch target that we use. This video illustrates this point perfectly. We start off at a distance of about 3 to 4 feet. Now, using the digital zoom, we zoom in electronically to see that we filled the spot meter completely. If you notice in the upper left-hand corner, the temperature measurement is about 99 degrees Celsius. Looks good. Now, however, at a distance of about 30 feet, we look at the same target with the same camera and the same resolution. And with that digital zoom, you can now see that we have not filled that spot size and we're recording a lower temperature value. We don't have sufficient resolution. Now, there's a lot more to resolution than what we've covered here, but at least we've introduced you to the basics. Going forward, you might want to consider a Level 1 certification course so that you can fully understand this really important concept for thermographers. And if you're looking for more, be sure to get social with ITC. You'll find us on Twitter, Facebook, YouTube, Instagram, or LinkedIn. You get the very latest, including upcoming training dates and locations, special promotional offers, and of course, valuable tips and information. Now, if you have questions about today's event, resolution perhaps, you can drop a question here in the comments field on Facebook and we'll get right back to you. Well, that does it for another week here at the Infrared Spectrum. We hope you enjoyed today's topic. We'll see you online again next week. Have a great weekend.